Hi everyone, in this particular video I'm going to be explaining to you about the changing brightness of an LED using the potentiometer, and this is being done with the help of an Arduino. This can be also done with the help of an Arduino and without an Arduino also. You just need a power supply and it can be done also. But here we are going to use some programming and we are going to understand mainly the function of a map over here. Okay, there's a function in Arduino programming which is called map, and that map function is what we are going to learn over here in this particular programming using this potentiometer based LED brightness controlling experiment. Okay, so what are the components required over here? You require an Arduino Uno, you require an LED, you require a particular potentiometer over here. Okay. So these are the main components that are required while for connecting this particular circuit over here. And you can see that all the components are available on the right side itself over here. You have the potentiometer over here, you have the LED over here, the resistor is also available over here, the Arduino Uno and the breadboard. Arduino Uno and the breadboard, both of them are also available over here. So all you need to do is connect them with the corresponding wires and write the program and you'll be able to execute it. So before we execute the program, before we look into the working of the program, let's look into how it is working over here. So I increase my potentiometer value and you can see that the brightness of the LED keeps on increasing over here. And when it comes to maximum, this is the maximum brightness over here. So as I keep on decreasing the particular potentiometer value, you can see that this particular value keeps on decreasing over here. So this is how I am controlling this particular LED with the help of this potentiometer over here. So how am I going to do that? We look into the schematic first and then we will look into the particular programming part later. Okay. So what are the components required? So you can see in this diagram we have a potentiometer, LED, resistor and the Arduino board over here along with the breadboard. So potentiometer, it has three terminals, the terminal 1, wiper and the terminal 2. So this terminal 1 you will connect it to the breadboard power rail terminal over here. Okay, so you'll connect it to the power rail over here, and the other terminal 2 you will connect it to the ground rail over here. So you should make sure that the power rail is connected to the 5 volt of your particular supply and the ground rail is connected to your particular ground rail of your particular breadboard. Later what you're going to do over here is you're going to connect the center wiper pin, and this wiper pin is an analog value. As you may see that it is going to vary from the minimum value to the maximum value. It is varying from point to point, so it is going to be an analog value over here. So you are going to connect this to the particular analog pin over here. So after you connect it to this particular analog pin, your next step is to connect the LED. So after you connect this particular LED over here, you can see that the cathode terminal is connected to this particular ground and the anode terminal is connected to this. So the anode terminal is connected to this particular 6 pin over here. Okay, so anode terminal, before it is connected to the pin number 6 over here, you can see that it is connected through a particular resistor. This is for reducing the excess of current that is flowing through the LED, which may damage it. Okay, so you can see that the resistor value used over here is 100 ohm. You can even keep it to 220 or 250 ohms, but preferably if you have a little bit lesser resistance, the brightness variation can be seen much in detail. Okay, so that is what you are seeing in this particular part over here. So two main pins that are being used over here, pin number 6 and pin number A0. And you can notice that I have connected to pin number 6 over here, which means that it is a PWM pin. Of the digital pins available, this is a PWM pin over here, which is used for varying the brightness. So you are connecting it to pin number 6 and you're connecting your potentiometer to pin number A0 over here. So now let's look into the particular coding over here. You can see that I'm having a variable that is declared for reading the potentiometer value, and that variable is called as read over here, and that I'm giving it before the void setup. And the other things that I'm declaring over here is the declaration of my particular input pins. Okay. So what are my input pins over here? My potentiometer. You can see that my potentiometer is equal to, it is equated to A0 over here. So I'm equating the variable potentio to the pin A0 over here, because this blue color wire is connected to this particular potentiometer over here. And similarly, the pin number 6 is connected to the LED over here. So that is what I have connected it over here. And red LED is equal to 6 over here. So inside the program, I will not be using the term A0 or 6 or N6. I will be using only the terms potentio and red LED. Okay. So you are aware that the potentiometer is given as input to this particular Arduino as analog input, and based on that the output is given to the LED. So potentiometer is the input and the LED is the output for this particular Arduino microcontroller over here. Now what I'm going to do is I'm going to create my loop function over here. In this loop function, what is going to be happening repeatedly over here is my particular first thing is reading the potentiometer value. So you have connected it to a not pin over here and you expect a continuous change in the potentiometer value. So you're going to analog read, not digital read the value of this potentiometer. So that is after reading this analog value of the potentiometer, where are you going to store it? You're going to store it in the variable by the name read. Next, I'm having my function that I'm going to vary this. According to my varying potentiometer value, I need to vary the brightness of this LED over here. So how is that taking place? So that is taken care by this map function over here. Okay. So you may be aware that this particular Arduino works on an 8-bit microcontroller here. It works on a 8-bit analog to digital converter. Okay, so which means that this A0 pin is an analog input. Every microcontroller or any device can understand only binary values, so there is an analog to digital converter available over here, and that analog to digital converter, what is going to happen over here is going to convert the bits from analog value into digital. So for that the minimum value is 0 and the maximum value is 1023. So the input, the minimum range of input value of A0 and the maximum value of that input to A0 is given by this particular value 0 to 1023. And the next two values 0 to 255, one is the minimum value and one is the maximum value, and that is for this PWM pin. So 0 to 255 is the particular minimum value and the maximum value for this particular fading of the LEDs. Fade in and fade out. If you look into the fade in and fade out of a LED, you will understand the 0 to 255 range over here. So what is happening in this map value? You are having the read value. What is that read value specify? Read value is the actual place in which this potentiometer is pointing to. So that particular value, and its limitation is specified with two different pins over here. One is with respect to the analog input pin over here, which has a range from 0 to 1023, and the other range is for the output to the LED, and that is having a range of 0 to 255 over here. So this is that particular map function. Now I will be getting a read value over here, and I'm going to divide that by 4, and that is what I'm going to analog write into my red LED. If you are going to make your LED to glow on and off, only two conditions you would give digital right over here. But here you're going to make sure that the LED is going to be on and it is going to be keep on increasing in brightness to the maximum. Later it is going from maximum to the minimum value here. So that is why you are going to give analog right over here. And which LED? The red LED is the one that you're connecting it to. And what is that value going to be? Read divided by 4. You're giving a condition over here that it is read divided by 4. So now when you look into this particular program, you'll be able to understand that this potentiometer value, when I'm varying it over here, you can see that it is reading a value and that value is having a range from 0 to 1023. So 0 to 1023 is this particular range over here of this particular potentiometer value. Next, this 0 to 1023 cannot be given directly to this LED over here. So you are going to change that range, and for this LED, you know that using the PWM, you will be having a range of 0 to 255. So that 0 to 255 is what you have given in this particular code for the output of this LED to change its particular brightness. So that is what is happening here, and you can see that the brightness is varied accordingly over here. Now it is nil brightness. Now it is half bright over here of its capacity, and now it is maximum bright. So this is the working of a LED with its brightness changed according to the potentiometer with the help of an Arduino microcontroller.